So we'll finish up section 2.1, part 2. And this is going to be focusing really on two different things. We're going to look at what's called arc length, okay, an area of a sector. Okay, we're going to start off with arc length. Okay, first thing I've drawn is this diagram. Okay, we've got a circle. And I've drawn not just one angle in it, but two angles. Okay, one angle is this circle with a line in the middle. Does anybody know the name of that Greek letter? Theta, yeah. T-H-E-T-A. It's theta. A lot of times when we don't know what an angle is, in trig we use a Greek letter to represent it. Just like in algebra you use x a lot. Well, in trig we use theta a lot for angles. Okay, so this angle is theta. The other angle I've labeled theta 1. I just needed a different name for it, but I still wanted to use theta. The arc that corresponds to theta I'm calling S, and the arc that corresponds to theta 1 is S1. So our goal here is to somehow come up with a formula that we can use to find the length of an arc in a circle. Okay, and the way we're going to do it is we're going to use a fact we already know to determine a formula. Okay, I'm going to show you an example first with a fact you're already more familiar with, and then we'll come back to this. Okay, let's say you wanted to convert feet to inches. What's the conversion between feet and inches?
1 foot is 12 inches.
Okay, so in 1 foot, there are 12 inches. Now, if you wanted to convert, any number of feet to inches, all you need to do is set up a proportion, just like that. And now let's say you had 10 feet. Okay. You just fill in 10 feet, and you want to know how many inches it is, and you solve that proportion. Okay, that's one way to do it. Now, does the fact that the conversion that I was just given, in 1 foot there's 12 inches, does that limit what numbers I can convert between for feet and inches? Like, can I only convert like 10 feet, or could I do any number of feet that I want? Yeah, just because he gave me a conversion that had a 1 and a 12 in it, that doesn't restrict me when I want to convert feet to inches. I could put any number I want here, and I could put any number I want for inches, and I could solve it. So the point is, you're using a fact that you know to start with. If you don't have that fact to start with, this doesn't work. All right, so now we're going to go back to our formula for length of an arc, and we're going to have to start with something we already know, or this isn't going to work. All right. So what I'm going to do is I'm going to use this smaller angle, theta 1 and S1, and I'm going to try to come up with this fact right here. Obviously, it's not the same fact, but it's a fact we already know that's going to help us out. If you make theta 1 a certain size, we automatically know the length of this arc. And this is going to tie in with something I showed you yesterday. And I said this will come back again today. Anybody remember that? Remember the relationship? If you make this angle a certain size, it automatically makes this arc a certain size.
Isn't the radius the same length as the arc?
The radius will be the same length as the arc if that angle is how big?
57.3.
Okay, and we're going to do it in radians.
So 1 radian.
1 radian, yes. So what we're going to do is suppose theta 1 is 1 radian. Based off what we learned yesterday, that automatically makes the arc the same as the radius. There's our starting point. This is going to be like our 1 foot and 12 inches. Right? All right, so suppose theta 1 is 1. I'll write RAD, but you don't need it. Then S1, somebody said it, would be equal to the radius. Okay. Now we're going to set up a proportion. The reason we can set up a proportion here is because the size of the arc and the size of the angle are directly related. If you double the size of this angle, then you double the size of the arc. If you made this angle half as big as it is now, you'd make that arc half as big. Okay, that's called directly proportional. When two things are directly proportional, you can use proportions. So we're going to set one up. Let's set up the big angle compared to the big arc, so theta compared to s, is the same as the small angle compared to the small arc. It's just like the same proportion I did with feet and inches. I'm putting angles on top, I'm putting arcs on the bottom. And we're going to fill in what we know. Okay? And then we'll simplify it a little bit. So theta we don't know. Just leave it as theta. S, we don't know that either. So leave it as S. This is the unknown side of my proportion. It's kind of like this side, before you fill anything in. It's the side you don't know. All right. And now we're going to fill in the side that we do know. Theta 1, we're letting be 1 radian. And S1, we're letting be R. Now, just because we picked theta 1 to be 1 radian, that doesn't limit what I can do to convert. Just like somebody picked 1 foot to 12 inches, that doesn't limit anything. It's just your starting point to figure out what you don't know. The right-hand side is just my starting point to figure out what I don't know. Okay, now how do we solve a proportion? What's the name of the technique you do? Yeah, you cross multiply. Okay, so we have S times 1. Amy, what's S times 1? Just, no, not 1. Or just S. You take S and you multiply by 1, it's just S. And then we're going to multiply the other diagonal. R times theta. That formula I just put in the box. That is your arc length formula. S equals R theta. Okay. S is the arc length. R stands for the radius. And theta is the angle. Now we have to be careful with the angle. We assumed way back at the beginning of this problem, what units am I working in for the angle?
Degree or radians?
Radians, yeah. So way back at the beginning, we assumed we were working in radians, which means if you have a problem and they give you degrees, you've got to change it. Okay, so theta is your angle in radians. Any question on that formula? This formula is only good for calculating the length of an arc on a circle. You can't use this for an oval or anything else. This is only for arcs that are on circles. All right, so first example, I've kind of written out all the details. When we go on, I'm going to kind of abbreviate because you don't need to write out this much information. But I want you to find the length of an arc. And I'm starting you off with a circle. Inside the circle, I'm going to draw an angle of pi over 3 radians. The circle is going to have a radius of 4 inches. Find the length of the arc determined by that angle and that radius. Okay, so the first thing, if we want, we can sketch it. Somebody who's more visual. Draw an angle. It's pi over 3 radians. And the radius is 4 inches. And what we're trying to find is that. How long that arc is. So really all we need is the formula, S equals R theta. And we'll fill in what we know. Okay, we don't know S. That's what they're asking us to find, the length of the arc. Okay, but we do know R. Okay, Andrew, what's R in this case?
4.
Yep, radius is 4. And theta, that's my angle. Okay, Kyle, what's my angle here? Yep, and it's already, he said radians. It's already in radians, so I can plug it right in. If it was in degrees, I'd have to deal with that and change it to radians. Now we just do it out. Here we go. So the length of the arc is, I want to think of it as a fraction, it's 4 pi over 3. And now I just need to put the right label on it. Okay, we just found a length. Okay, we measured a length. In this problem, what was my unit of length? Inches, right. Okay, sometimes people say radians. Radian is not a unit of length. That's an angular measurement. So if you're ever finding an angle, then you use radians. But in this case, it was inches. And that's it. That's how you find the length of an arc. If they wanted a decimal, approximately how big, just type it in, and it's about 4.19 inches. Okay, about 4.19. Most of the time, I'll probably just let you leave it exact, but I will let you know if I want a decimal. Questions on that one? Let's try another one. This time, instead of writing out a whole description, I just drew a picture and told you what I want you to find. So I want to know the length of the arc. Right there. Okay, there's two different things we're going to practice finding today. One is arc length, the other one is area. So first thing you always want to do is write down the formula that you think you're going to need. And it's either going to be one of those two. We haven't done area yet, so you don't have to worry about what the second formula is right now. Okay, so this is arc length. Right, so Andy, what's my formula for arc length?
S
Yep.
equals radius and now we'll circle.
Yep, so S equals the radius times, anybody remember the name of that? Theta, yeah. Okay, my radius, how about Michaela? What's my radius?
8.
8. And Sean, what's my angle?
130.
Okay. Any thoughts about using this angle in this problem?
You have to put in radians before.
Right. First thing we have to do is change 130 degrees to radians. So I'll write it down. But at the same time, I'm going to multiply by the conversion to change degrees to radians. I just need to throw in a pi over 180. Okay. And then the degrees will cancel out. And now we can just do this out. We have 0 in the top, 0 in the bottom. We can cancel. And now we can do 8. Well, actually, we can reduce it even more. What goes into 8 and 18? 2. So 2 goes in 4 times. 2 goes in 9 times. Okay, so we're left with 4 times 13. It's 52 times pi. And in the denominator, it's just a 9. And what should be my label on this one? Feet. 52 pi over 9 feet. Again, if you want the decimal, just type it in. Questions on that? All right, so there's really 3 different kinds of questions I can ask you with this formula. I can give you r and give you theta and have you find s. Or I can give you s and r and have you find theta. Or give you s, give you theta, and have you find r. Either way, I'm always going to give you 2 out of 3 of the variables. And you're going to find whatever I want for the third one. Let's try that on this one. Okay, so this time I'm telling you the arc length is pi over 4. Giving you the radius, I want to know what the angle is going to be. Okay, so I've already written down the formula you're going to need, s equals r theta. All right, Max, what's pi over 4? Which letter is that? In s equals r theta, where's the pi over 4 get plugged in?
That would be the radius,
Well,
Yes.
second part's telling us the radius, so that's your s, yep. Okay, so you got pi over 4. The radius is 12 times theta. Okay, how do I solve that equation for theta? Well, Iris? We get theta by itself. You have to do, yep, divide each side by what? By 12, yeah. So you divide this side by 12. If you're dividing this side by 12, it's just like throwing a 12 in the denominator. Think of it as multiplying by 1/12. 12s cancel. And we get 12 times 4 gives me 48. So we get pi over 48. That's my angle. Do I need a label on it? No. Some people say no, some people say yes.
No, because it's in radians.
Right, this is a radian. Okay. If it's in radians, you don't need to label it RAD, and I won't on the test. Any question on that? Okay, so one question that I usually end up putting on the test is a problem just like this. And I list all my answers in degrees. So if somebody gets this as an answer, pi over 48, and they're like, I've done it 5 times, and you don't have pi over 48 listed. Pi over 48 is a radian. If you look at my answers and it's a multiple choice question, and they're all in degrees, you would have to convert that to a degree to make it match my answer. All right. Any question on that? Okay, so just be careful with that. Look at the units, look at the label on the answers. And if it's in degrees, you got to convert it. Okay. All right, so we'll do, I'll let you guys try one more with arc length. This time I'm giving you the arc, the angle, and I want to know the radius. Okay, so try that one on your own. See if you can get the radius, and we'll take a look at it in a minute. Let's take a look. So we know this is a problem involving s equals r theta, because they're giving you an arc, they're giving you an angle, and they're asking you to find a radius. If they were giving you an area, that'd be a different formula. Right? That's the last one we'll look at. Right, before we even fill in s equals r theta, what do we need to do first? Yep, Sarah?
Change the degrees to radians.
Yeah, if you want off to the side, before you even fill in for theta, you can change degrees to radians. So what do we multiply by to do that?
Pi over 180.
Pi over 180. Okay, so degrees cancels out. And 36 will go into 180 nicely 5 times. Okay, so there's my angle. It's pi over 5. Now I can fill in my formula. So my arc length is 13. My radius, I don't know. That's what they're asking for. And multiply by pi over 5. Okay, so we want to get r by itself. So we need to get the pi and the 5 on the other side.
And then divide by pi over 5.
Yep, you can divide by pi over 5, or what can you multiply each side by that's the same thing?
5 over pi.
5 over pi, and multiply by the reciprocal. It's the same thing. It's just a little neater to write it this way. Okay, so on this side, the 5's cancel, the pi's cancel. You get r equals 5 times 13 is how much? 65. 65 over pi. And because that's a radius, that's a length. What should be the label on this one? Feet. Feet. Okay. Radius is a length, arc is a length. The angle inside here, we use radians to measure that. So 65 over pi feet. All right, any questions on that? Okay, so S equals r theta. That's your formula for finding the length of an arc. Okay, next formula we're going to look at, last formula, has to do with the area of a sector. Okay, first of all, a sector, you can basically think of it as, it's almost like the shape of a piece of pizza when the angle is small. Right? It's the area of everything inside, between the two sides of the angle. Okay? So a sector has two straight sides, determined by the angle, and it has one curved edge on top. That's the perimeter of a sector. Okay, and I've set up a diagram just like we had. I have a larger area, which I've called A, created by an angle of theta. Then I've got a smaller area down here, which I'm calling A1, created by a smaller angle, which I'm calling theta 1. Just like we did before, we've got to have a starting point. We've got to have that in 1 foot there's 12 inches. Okay? Now we've got to let theta 1 be something again. But this time letting it equal 1 doesn't help. That's good for the arc length, but it doesn't help with the area. Any thought on what I could let theta 1 be? And if I let it be this, I'd automatically know the area. Well, instead of thinking about, say, a sector, what happens if a sector gets so big that it takes up the whole thing? What are you really finding the area of in that case? If the of the circle. Okay, so if we let this angle be so big that it takes up the entire circle, you're finding the area of this whole thing. Well, hopefully from geometry, we already know how to find the area of that whole thing. And we can use that fact to help us out. So what would theta 1 have to be if that angle is going to take up the entire circle? 360 in degrees? Yep, perfect. Or how much in radians?
6.28
Or 2 pi, yeah. So if you let theta 1 be 2 pi, then area 1 would become the entire circle. The only thing we need to make sure we know is the area of a circle. What's the formula for area of a circle? Pi r squared. And just because we picked these two facts to use, it's just a fact we knew. Just like in 1 foot there's 12 inches, these numbers don't limit us to converting or finding anything. We can use this fact to figure out anything we want. And again, we'll set up a proportion. The size of the sector and the size of the angle are directly proportional. If you make this angle twice as big, you make the area twice as big. If you make the angle half as big, you make the area half as big. So our proportion will be A is to theta as what's going to go on the other side?
Pi r squared is to 2 pi. Well, I mean, after you plug everything.
Yeah, after you plug everything in, but yep, you had the idea. A is to theta as A1 is to theta 1. Okay, he had jumped ahead and actually filled in the two values that I put in the boxes. A we don't know. Okay, theta we don't know. A1 we do know, and we're going to fill it in. Okay, it's pi r squared. And theta 1 we know, we're going to fill that in. It's 2 pi. We're going to solve that proportion just like we did before for A, and that's going to give us our formula. But is there anything I can do before I start to solve that I can try to simplify a little bit?
You can cross out the top pi and take one off the bottom.
Yep. We have a pi in the top and a pi in the bottom. We can cancel it out. If you don't want to do it now, you can do it in the next step. But either way, you're going to have to cancel out pi eventually. Right, and now we cross multiply. We're going to do A times 2, which we normally write as 2A, equals. Now multiply this. Theta times r squared. Any question on that so far? Okay. Now, the only thing we have to do is we have to solve for A. Okay, right now we have 2A. So we just need to get the 2 on the other side.
Just divide by 2.
Yeah, just divide by 2. Divide each side by 2. And that's going to give us area equals. Instead of dividing by 2, how can you say the same thing with multiplication?
1 by 1.
Yeah, in the book, that's how they write it. They write it as 1/2. And they end up switching the order of theta and r squared. That's just how they write it. A equals 1/2 r squared times theta. And that's the area of a sector. So A is area, r is your radius, and theta is your angle. Same restriction on the angle we had with the other formula. You've got to do this in radians. Any question on how I came up with that? 1/2 r squared theta. All right. So I can ask you 3 different types of questions. I can either ask you to find A, R, or theta. We'll try. This time I'm only going to do one of each. The first one is for the area. Okay, you get an angle of pi over 6 and a radius of 4. Okay, Yadira, what is my radius in this problem?
4 centimeters.
Yep, 4 centimeters. So keep that in mind when we find area. Area has a certain type of unit. So that's important that we label it correctly. 4 centimeters squared. And my angle? Tom, what's my angle? Pi over 6. Yep, pi over 6. All right, so we'll do that out. Ben, what's 4 squared? Not 4 times 2,
I
but
think it's 16.
yeah, 16.
Ooh,
Yep. Now, well, you kind of jumped ahead. Now, what's half of 16?
8.
That's 8. So we get 8 pi over 6. And Paige, is there anything I can do to reduce 8 and 6? Divide it by 2, and it'll become,
4 and 3.
yep, 4 pi over 3. Now that's an area. So what kind of label should I have on that?
Centimeter squared?
Centimeters squared, yes. So I go back, I look at my problem, look at the units they used. They used centimeters to measure length. So area is square centimeters. Okay, any questions on that? Okay, so that's one type, find the area. Okay, second type, find the radius. Right, so I got an area. Even if I didn't write the 8 pi over 3 inside the sector, you'd still know it's an area. Just look at the label on it. It's square inches. Right, so first thing I want to do, just start out with the formula. Okay, Zach, what's my formula for area of a sector? So that's closer to the arc length one. S equals R times theta. But do you have it? You can look in your notes. That's fine. You don't have to have it memorized yet. You don't have that? Anyone help them out? What's our formula for area? Yep, Ben?
A equals 1/2 of R squared. Theta.
Yep. A equals 1/2 R squared theta. Okay, Owen, what's A in this case?
8 pi over 3.
Yep. So 8 pi over 3. Good. Okay, 1/2. We're finding the radius, so we're just going to leave that. We don't know it. And theta is 45 degrees. Anybody know what that would be as a radian? Pi over 4. Very good. All right, so our goal is to get R squared by itself. So eventually we need to get the 1/2 on the other side, the pi, the 4, and we need to deal with that exponent of 2. The exponent's the very last thing we deal with. Okay, how can I start to move some of this stuff to the left-hand side? You can do, if you want to try to do more than one thing at a time, we can, or just do one at a time.
You can multiply 1/2 by pi over 4.
Sure, we could combine the 1/2 and the pi over 4. 8 pi over 3 equals 1 times pi is pi, divided by 2 times 4 gives me 8. Okay, so half of pi over 4 is pi over 8. Okay, and we've seen this before, where you've got a fraction in front of a variable. What can you multiply each side by to get the pi and the 8 on the other side at the same time? The reciprocal. Okay, what's the reciprocal of pi over 8? 8 over pi. And 8 over pi. It's going to cancel the pi's, and that's going to cancel the 8's. So we've gotten rid of everything on the right-hand side except the exponent. 8 times 8 is 64. Actually, what else can I cancel on the left-hand side now? The pi's. So I might as well do that. So it's 64 over 3. And my last step, I got to get rid of squared. Square root both sides. Okay, when you square root a fraction, the way you can do it is you can square root the top and bottom separate. So it's going to give me R. And the square root of 64, that comes out nice. We can do that. How much is square root of 64? 8. Divided by square root of 3. And what do you do to get the square root of 3 out of the denominator? Yeah, multiply top and bottom by root 3. Okay, so if you got this as an answer on the test and it didn't match up with what I have, it's probably because I didn't leave the root in the bottom. So you get 8 square root 3 over 3. And my original units here were inches. Okay, so that's in inches. Okay, that's the toughest one. Okay, because it's got the square in it, so you end up taking the square root. That one takes the longest. Any questions on that one? All right, so we'll finish up with this one. Okay, the area is pi over 2, radius is 3, find the angle. Okay, why don't you try that one? See if you can do it. I'll walk around and I'll help you out. You're not going to have to worry about taking a square root though this time because I'm giving you the radius. All right, so first thing you want to look at is look at what they're giving you and decide, is this going to be a problem that I need s equals r theta for, or is it a equals 1/2 r squared theta? They're giving me an a, so I know it's the formula that has a in it. Okay. Fill in a, pi over 2, 1/2. If you want to do 3 squared and all in one step, you can, or just plug it in for now and simplify it later. Okay, so we get pi over 2, 3 squared. How about Ashley? How much does that give me? 9. And then take half of it.
4.5.
So yeah, you could leave it as 4.5 or just even as a fraction. You don't even have to do the decimal if you don't want to. And now I just want to get 9 halves to the other side. And in a second, you'll see why I left it as a fraction. Right, so how about Iris? What do I multiply each side by to get the 9 and the 2 on the other side?
2
Yep, 2 over 9 and 2 over 9. 2's are gone, 9's are gone, and the reason I left it as a fraction, the 2's are going to cancel out anyway. So we get pi over 9. What's the units on pi over 9? It's radians, right? I don't need to write it, but it's an angle, so it's assumed. Okay, so that's the 3 different things I could ask you for with the area formula. Okay, in the homework, they're going to give you a couple questions about arc length and area having to do, one has to do with a clock, and one has to do with a pendulum swinging back and forth. Okay, on a clock, they're going to give you a problem like, say the minute hand was pointing right at noon, and then later on, 20 minutes later, it was pointing at the 4. And I want you to find how far the tip of the minute hand moved. What am I really asking for in terms of what we learned today? It's an arc. Okay, the tip of the minute hand is going to move in a pattern just like that. Well, the book will end up giving you the length of the minute hand. What is that like, the length of the minute hand?
Radius.
That's your radius. Okay? The only thing you need is the angle. But since you're on a clock, everything is equally spaced. So there's 360 degrees all the way around. One way to think about it is, what's the angle between 12 and 3? That's a 90. So how many degrees does the minute hand move every 5 minutes? Yeah, 30. Right? So between 12 and 4, how many degrees is that? That's a 120 degree angle. So you get the length of the minute hand, you've got your angle, you can find your arc length. Okay, so you're going to have a couple problems with a clock like that. Okay, the other problem is a pendulum. They're going to tell you the length of a pendulum, and they're going to ask you how far it swings back and forth. Okay? Well, as a pendulum swings, what's the path that it traces?
Circle or arc.
Well, it'd be a circle, yeah, if the pendulum went all the way around. But if it's only swinging back and forth, it makes an arc. So they'll tell you something like it's a 40 degree angle. They'll give you the length and ask you to find the arc. Okay? So they're not too hard as long as you try to think of the problem in terms of what you learned today. So on the same page as last night, page 99, have you guys do 71 to 87 odd and 91 to 94 all.